Thanks, Daniela, for analyzing the code for us.
You're
High
welcome,
five.
Jamor. High five.
Perfect. Now, instead of launching the ball with these initial conditions for position and velocity, let's see what happens when we change them around a little bit. And to do that, how about we use the use mouse feature? So let's come back to our assignment guidelines. And over here, you see copy to code under use mouse equals true. Let's copy that, go back to our editor, and somewhere here in the beginning, maybe even right under where I define X and Y, I will paste down the use mouse equals true. Now, what happens? If I just press play now, seems like everything starts out normally. But if I want to change my values, I can click on the screen somewhere. Let's say over here. I can drag the red arrow down to whatever value I want. And the farther I drag it, the greater the initial velocity I'm giving it. And if I let go, we can see what kind of an orbit we get.
Oh, that came really close to the sun.
Yeah, so it's probably a good idea for us to try redrawing this somewhere else. Maybe with the velocity arrow that points a little bit farther away from the sun. Okay, I think that's better.
That looks really cool. I have an idea, Jamor.
Yes.
How about if we compare these new areas with the velocity you drew with the mouse and see if it matches up with the percent error from the last run?
I like that idea. Kepler never told us anything about the initial conditions of orbiting objects. So if they change, we'll see if the results change or not.
Yeah.
All right. Since I just used the use mouse feature, I can no longer right click to save these images. So what I'm going to do instead is just use a simple hack where I press print screen on my computer. And for simplicity, I have a paint window open where I'll just copy and paste a screenshot and I can read off the values to Daniela. So are you ready for them?
I am ready.
Okay. And in your document, I guess this can go under the using mouse heading. We have area 1 equals 6326. And area 2 is 6189.37.
All right.
Okay, go back to screen grab and do it again. All right. Now we have area 1 equals 6301.48.
All right.
And area 2 equals 6198.28.
Got it. And how about we just do one more just to get the third data point?
Sounds good to me. And we just took one now. And those values are for area 1, 6309.94. And area 2 is 6180.03.
Got it. So how about we go back into our little Google sheet and see what we get with these new areas?
That sounds like a good plan to me. So
right.
I will allow you to share your screen now.
Okay. Thanks, Jamor, for telling us about area 1 and area 2, but now with the mouse. And you see that the numbers of area 1 and area 2 are bigger than when we didn't use the mouse. So why don't we go ahead and use the same equation to figure out the percent error. Now remember, first what we did was find the average. And in order to do that, I wrote down equal, open parentheses, and I did area 1 plus area 2, and I divided this by 2. And there I got the average. And remember, like I mentioned before, Google Sheets is pretty smart. So if I just grab this and drag it down, it's going to know to take the average of this second data point and this third data point. Now we're going to get the absolute value of the difference of, remember, the measured minus average. So the measured, we're just calling area 1. So we're going to do equal, open parentheses, area 1, hang on, equal absolute value, because remember, take the absolute value of area 1 minus the average. Close parentheses, hit enter, and there's our difference. And again, I'm just going to click on this, drag this all the way down, and it calculated all the differences for me. Okay, and finally, we're going to figure out the percent error, which we're going to use the same equation to figure out. So we're going to say equal and put 100 times this absolute value of the difference we calculated in this column. So I'm going to open parentheses and click that. And I'm going to divide this by the average, which was column D. I'm going to hit it and click enter. And look at that. Our percent error is still at about 1% for this data point. So if I drag this down, it's still about 1% for everything else. I think that's pretty awesome what we did, Jamor. Even with your mouse clicking, we got the same percent error as what we were expecting.
Excellent work, Daniela. Thanks.
Thanks, Jamor.